Alright guys, so we are now into our last section of this unit. This is going to be 15.4. We're going to use a lot of the ideas from this and kind of put them all together to make decisions in this unit. As always, we have our learning targets. You should be able to, at the end of this, interpret a normal curve in terms of probability, and then use normal distributions and probabilities to solve problems. Alright, as far as probability goes, so far we've explored finding percentiles, z-scores, percent of data in an interval. So like if I said it's above or below a certain amount, we've been able to find that. Okay, to bring this unit together, we'll be discussing how this is actually used to make predictions and make decisions. So we'll answer questions like, determine the probability that a randomly selected student scored better than 80 on the test. And so what you would do is you would compare that with, if they're normally distributed, then you'll use your z-score to figure that out. Alright, let's look at our first example. Alright, so suppose the number of Snapchats high school students send in a day is normally distributed with a mean of 21 snaps. Okay, so let me mark what's important here. Okay, 21 snaps and a standard deviation of 1.8. Okay, so mu equals 21, sigma equals 1.8. Determine the probability that a randomly selected MVHS student sends less than 15 snaps per day. So think about what this is asking. Since it's normally distributed, it's going to have a bell shape. Okay, here's 21. Okay, 15 is somewhere out here, and I'm trying to figure out the amount or the probability of people less than that, so the area beneath that point. Okay, so in order to do that, I need to find my z-score. So z equals x minus mu over sigma. So in this case, it's 15 minus 21 all over 1.8. Okay, so I take out my calculator. Let me get to it real quick. And I go 15 minus 21, enter, divided by 1.8, and I get negative 3.3 repeating. Okay, so z equals that. Okay, so what I'll do then is go to my z table, and I'll try to look up negative 3.3. So negative 3.33 I got, so this z-score corresponds to 0.0004. So what this is saying is that if the mean is 21 and the standard deviation is 1.8, there is less than a 1% chance that a high school student selected at random sends less than 15 snaps per day. Okay, so that's how we'll use this probability. Okay, because remember, when you look up in a z table, okay, the percentage is always below. Okay, so if, for example, if I ever ask if you want to go above, remember that we'll have to subtract that amount from 1. Sort of like in this example, determine the probability that a randomly selected MVHS student sends more than 30 snaps. And I'm actually going to change this real quick. I'm not going to do 30. I'm going to do sends more than 25. Okay, it sends more than 25. So again, normal curve. 21 is here. I have a pretty low standard deviation, so most of my data is towards the middle. Okay, 25 is out here, and I'm trying to find the probability more than, so that's going to be out here. So remember, when I do a z-score, that it always tells me the area less than. So I'm going to have to subtract that from 100% to actually get my answer. So let's find our z-score first. So z equals x minus mu over sigma. And z equals, so let's see, x was 25 minus 21 all over 1.8. Okay, so take out your calculator and you go 25 minus 21 divided by 1.8. I got 2.2 repeating. So 2.22. Okay, so again in my z table I'm going to look up 2.22 and see what the corresponding number is. So go to your z table, we're now on the positive side. And you go to 2.2 and then over to 200ths. And I got 0.98, let me get it correct, 9868. Okay, so what this is saying is that 98.68% of data is below 25. So that's this one. Okay, so not the one that is the answer to our question. So all we have to do is we have to take 100 minus 98.68. Okay, because remember under the whole curve is 100%, and that'll be our final answer. So if you need to take out a calculator, that's fine. 100 minus 98.68 is 1.32%. Okay, so there is only a 1.32% chance that a student sends more than 25 snaps per day. Now, you may think that's a pretty low percentage for something that's so close to the mean. But remember, when we talked about standard deviation, when standard deviation is low, okay, our data is all really close together around the mean. And so, this short gap, if you imagine, if 1.8 is my standard deviation, that's close to 2. Okay, so this is more than 2 standard deviations away. So if you imagine, if you went 2 standard deviations according to the empirical rule, that would be 95% of your data, and so there would only be 2.5% left in the tail. And so this is actually even more than that, which is why our number is so low. Alright, so we've done an example where I've done below. Okay, so I've done below, I've done above. Now we need to do again between data sets. So between 20 and 30. I'm going to change this. Actually, I'm not going to change that one. 20 is fine. I'm going to go between 20 and, I don't know, let's do 23. Okay, so we're going to go between 20 and 23. So if you imagine on our normal curve, 21 is again in the middle, 20 is over here, 23 is over here. We're trying to find this area in between. Now, a lot of people get tripped up on this because they want to say that it's 68 just because of how I draw this, and they don't think clearly right from the beginning. But remember, I have to be exactly 1.8 from my mean in order to use the empirical rule, and 23 and 20 are not exactly 1.8 away. So again, I need to find both of my z-scores. Okay, so for the first one, it's 20 minus 21 all over 1.8. And so z equals 21 minus 20 divided by 1.8 is 0.56. Okay, I'm going to round that to 0.56. Okay, and then my other one, z equals 23 minus 21 all over 1.8. 23 minus 21 divided by 1.8. And you get 1.11. 1.11. Okay, that's Z. Alright, so if you imagine, when I look up this Z-score, it's going to tell me the data that's below 20. Okay, so it's going to tell me this one. Okay, not exactly what I need, but that's okay. So let's look that up in our Z table first. So 0.56. And technically, I believe it should be negative 0.56. Okay, because 20 minus 21 was negative 1. So let's see. Negative 0.56 I got as, okay, so this is over here, 0.2877. Perfect. Now I'm going to look up 1.11. Remember 1.11, that was to 23. It's going to tell me all of this area. So this entire thing, including the black area, including the red area. And so if you imagine, what I'm going to do is after I find this, the black area, which is just the middle here, is going to be blue minus red. Okay, because if I take the blue area and then subtract out the red area, I'll be left with the black area. So, looking up 1.1, so 1.11, I get, let's see, 0.8665. Okay, so if you imagine, what this means is that this is 86.65% minus 28.77%. If you take your calculator and subtract those, so 86.65 minus 28.77, and you get 57. That did not work out. Erase that. You get 57.88%. And that would be your final answer. Now, I did all of these examples with my Z table. If you like using your calculator and using the normal CDF function, feel free to use that. Okay, because on the test you'll be able to use your calculator. There's only a certain portion where you will have to use a Z table. As always, if you have questions, make sure you stop me and I can explain things better. Alright, looking back at the learning targets, by now you should be able to interpret a normal curve in terms of probability. So the whole random selection process and like the possibility that we can randomly select something. And then you should be able to use normal distributions and probabilities to solve problems. Okay, so like ours was all determining how many snaps per day a randomly selected student would send. Your assignment is again section 15.4. Okay, section 15.4 and the 15.4 assignment. After this section you will be doing the normal distribution review, and then after that you will be ready for the unit test.